My name is Matt Rose. I am the Director of Application Security Strategy for Checkmarx. I've been in the static analysis and application security space going on 12 years. Had a lot of different roles, from technical to business development, and I'm basically, it's a long convoluted title, but the subject matter expert around application security strategy and implementation for Checkmarx. I have a little different style in my presenting. I really like it to be interactive, so I'm gonna not just speak to you. Please, I like it to be interactive. If I ask questions, feel free. I don't bite. There's really no right or wrong answer in terms of discussing the topics. And you don't have to agree with what I have to say. I mean, we're here to learn. We're here to learn from different experiences, from your colleagues, from the other sponsors of the event. So please, jump in. We'll have a conversation, and hopefully you'll get something valuable, hopefully a couple things valuable out of the presentation today. The title of the talk is Molehill Vulnerabilities May Become Mountainous Exploits, which is a tongue twister. I didn't create the title, I just delivered the message. But really what it's about is when you think about your application security program, it's not about the bleeding edge silver bullet vulnerabilities, that disassociative issues or vulnerabilities by themselves that are harmless, when brought together with other harmless dissociative vulnerabilities, you have an exploit. I have an application that kind of shows, or a demo of an application, a recording of the flow to show how this actually would happen within an application. So with that, we'll get started. So before we start, that was kind of what I just did, so a little ahead of myself here. What doesn't work and why? When you're fixing vulnerabilities, when you have an application security program, what works, what doesn't work, what are food for thought when you introduce a program? We're going to go over that. How two medium vulnerabilities generate a powerful exploit. These are the things that we're seeing today with the vulnerabilities in the press, in the media, all these type of things, because it's usually a couple small things that are deemed unimportant or do not fit your security policy that have been signed off. The risk has been accepted. What is your risk appetite? It's been accepted by the organization, but they don't realize a couple things brought together formulate an attack. Analogy I like to kind of use here is, I'll use a superhero analogy. Batman has the utility belt. He has pockets for all these grappling hooks and everything like that. And he has pockets of component A, component B, component C. By themselves, they're completely harmless. But if he brings them together and throws them at you, now it's an explosion, a smoke screen, fire, whatever it is. You have to think the same way about the vulnerabilities. There's risk. It's about the risk being brought together to formulate an attack. And when you're developing your applications, you have, especially with the DevOps movement, the CI/CD processes, that train's going down the tracks at 1,000,000 miles an hour. You have to take the time to remediate these vulnerabilities while they're happening rather than wait and accept the risk, because that's where the danger happens. You have to identify and remediate, not just identify. And how it should work and why. This is the program or our suggestion on how it should work. Again, it may not work for your organization. It may work for some of the groups within your organization, but it is very fluid. There is no silver bullet for application security. Everybody knows that. There's different processes, different things that need to be thought about, and you have to be fluid and accommodate different development processes, methodologies, and just overall culture within an organization. Let's agree on some initial statements. You can agree or disagree. I'm totally fine either way. Code vulnerabilities are at least important as quality bugs. A bug is a bug is a bug. And what I really preach is, again, remediation, not identification. And why do you go down processes of going down a different cycle for remediation? If it's a bug, just like a quality issue, something functionally doesn't work in the product, you go through a QA process, a defect tracking process. Vulnerabilities that are associated with security should go down that same process. They should be the same thing in terms of implementation for remediation. Developers should remediate vulnerabilities. Again, the biggest thing, and I'm going to preach this over and over again. I talk to some of the largest organizations in the world, if not the largest organizations in the world, and it's about remediation. You have to fix the vulnerabilities. You cannot just identify. A lot of the organizations that we're hearing in the press right now with major breaches over the past 6, 12, 18 months, they've spent a lot of money on bleeding edge security technologies, but they felt they were safe just because they had them in-house. You have to implement them correctly and use them to remediate, not just identify. Not all vulnerabilities can be leveraged to create an exploit. Checkmarx and my organization and my expertise is in static analysis. There's always the question or the granular discussion about false positives and false negatives with static analysis. They say nobody could do anything with that. That's, developers fight back and say, this is not an issue, nothing, the sun, the stars, and the moon have to align for that vulnerability to come to light. Well, if A, B, and C happen in concert, you're going to have a vulnerability. So even though a vulnerability is not exploitable by itself, there may be things that change. You may have an internal application that is designed for employee use, whatever that is internally, and all of a sudden you decide, hey, this is a great application. Let's expose it to our customers, expose it to our partners. Now the intended audience is different, and the threat landscape is much bigger for that vulnerability. So you have to think about these things and remediate them effectively. Remediation of vulnerabilities is not straightforward for all developers. Again, vulnerabilities, a lot of times you hear, prove it. Prove it. How does this happen? Interesting story from a past life. I was dealing with an organization, and they found a vulnerability, a buffer overflow in an application. The security team did. Went to the developer, the lead developer. He's been working on this product for 10, 15 years. Said, this is an issue. This is a vulnerability. He denied them, kicked them out of their office, said some choice words. And the security team went back. It took 3 people a week, and they ended up finding a way to cause that buffer to overflow within the application and for the application to crash. They went back to him, showed him, he swore, said some choice words, fixed it in 5 minutes. So thinking about that, fixing the vulnerabilities is much easier from a holistic standpoint, and understanding how to fix them and why you should fix them is very, very important. It took them, 120 man-hours to prove the vulnerability, when the actual remediation of the vulnerability or how to fix it was only 10 minutes in terms of time. The earlier the detection, the easier it is to address the findings. That's probably pretty common knowledge in here, but you'd be surprised. A lot of organizations are reactive to security and the vulnerabilities in their applications rather than proactive. And we'll beat a dead horse with the term of shift left. Shift left in the SDLC, the further the left, the easier it is to fix the vulnerability, the less cost it is, all the metrics by all the analysts out there about how much cheaper it is to fix an issue early. That is all true, but putting it to practice is usually challenging. And being reactive late in the life cycle is not effective. This is what usually happens to kind of give evidence to the point. You have your SDLC across the bottom, and again, I'm not a huge proponent of SDLCs being depicted as linear. I really don't think, because especially in the way we develop applications today and with the CI/CD process and the DevOps process, you design, develop, build, test, deploy. That looks like a sentence to me. It looks like the way we're displaying this here, and this is very common in any documents or any software development lifecycle books you read, is a period at the end. Okay, deploy, it's done. No, applications and your software that runs your business and helps your customers do the things they need to do, from financial to retail to healthcare, those applications are living, breathing things. They never stop being in development. They say that's in production, that's in development, that's a legacy app. You make one line of code, that application is different. There's new risk. And sometimes the biggest vulnerabilities are introduced when you go outside of the normal process of your software development processes. Thinking about it this way, if you have a check and balance, but all of a sudden there's a vulnerability or something that happens from a functional standpoint, they put a quick hotfix in, that may introduce the risk because it's gone outside of the process. So you want to make sure that you are pushing left. Penetration testing, very late. You have to have a buildable application running, stood up, tested against. It's very late in the process. What happens if that vulnerability is identified? How do you actually make sure that it's remediated and not delaying that release? Because DevOps and the CI/CD processes are designed to go quickly, and security cannot be a roadblock very late in that process. The security conscious organization, it's shock and awe. You do dynamic testing, static testing, manual testing against an application, you're going to come back with a laundry list of vulnerabilities. Developers freak out on this because if they're not aware, if it's not pushed left, if they're not identified early and communicated between the security team and the development team working in concert, you're going to have issues. You're going to have pushback where they say, I don't have time for this, I have a release I have to get out the door. And it causes people to scream. It really does. And the biggest problem here is we do not want to introduce the concept of security conscious organization hot potato, throwing it over the wall. Hey, go fix it. Not all vulnerabilities are created equal. Prioritize and remediate your efforts. But the question is, who is responsible? How do you prioritize? Is severity enough? Who is in charge of prioritizing the vulnerabilities? Thinking about those vulnerabilities that aren't exploitable unless they're combined with other vulnerabilities. How do you work with this? And this is where you really need to not just throw it over to development. Security and development have to work together to define this. One way is training. One way is letting them know what they're being tested on early. Don't have that penetration testing or that even that static analysis via a third party or in-house done late, because that's the hot potato approach. You're throwing it over the fence, you're hoping somebody does the right thing, and it's not going to work in terms of your release cycles. So I've just said a lot of words. Any questions or concerns or just general comments from the audience up to this point? And again, I don't bite, and I'd love to hear the opinions. I'm sure your colleagues that are here at the conference also would love to hear any questions or real life examples that you'd like to share about anything I've said or anything that's kind of stirred something in your organization or your experience?
Yeah, I was curious as what your thoughts are on the. I kind of feel like the waiting until the end to do the security testing actually encourages bugs to not be fixed. That's my theory. So I feel like if you wait so long to the end, then it's like, oh, well, we have to deliver. We're gonna put it in production. We'll just write down those vulnerabilities over here and worry about it later. And then they never get fixed and they sit around for a while, unless somebody's constantly pushing them. Do you feel like that's the way that waiting actually affects it, and pushing it left would then actually increase the chance of them being fixed early and often?
Absolutely. That's the concept of identification versus remediation. And usually in those situations, there's a lot of risk being signed off. Okay, I'll accept the risk. It's all about likelihood of the vulnerability. If they say it's really bad if it happens, but it's probably not going to happen, so they sign off on the risk. So that very late in the process, and that's where the business comes in and pushes the application or the new feature release or the new version of the product out the door, because it's revenue generating. It's very important to get it out the door, and that's why pushing left and being part of the design, develop, test, and then the release to include security. But you're correct in that if things are all of a sudden identified very late, that's not baked into the product or the program to release the product. So they don't know what to do at that point. So identification early and remediation early and communication of a policy. One of the biggest things that I suggest organizations to really do are two key factors. They say, I want an application security program. I want a secure software development lifecycle. And I'll ask them, do you have a security policy that you enforce that is clearly defined and communicated to development staff and everybody in the DevOps process or the SDLC process? And do you have an application threat inventory? Because you have different levels of testing you do against your financial application that is the primary revenue stream for the organization compared to the internal application that you'd use to order lunch. So thinking about that, have a policy that is very clearly defined, and it can be OWASP top 10, it can be something homegrown, it could be, and I think a very small subset to start a program is more beneficial because it doesn't overwhelm the developers. That previous slide where we had, the screaming of the development staff, we really need to communicate that early so there's no screaming by the development staff. Does that answer your question or back up your statement? But I agree with you. Anyone else? Questions in the way back? Okay.
Could you repeat the question for the recording?
So the question's more about developers relying on defaults in frameworks and stacks. Like an example would be like Spring Framework, where they're like, okay, I'm not even setting defaults. I'm just relying on the defaults within the stack and not realizing, oh, if I change this version, what's going to change?
Yeah, absolutely. I mean, that kind of bleeds into the use of open source components across the board, where you're assuming a component that you're using in your application is secure in itself. But again, once you add that or Spring or whatever it is, a third-party open source charting package as part of the application, if that is insecure and causes the homegrown code, which is secure to be leveraged, that is of concern. And just arbitrarily saying, I'm going to just accept the defaults because that's what everybody else does is not a good plan. Because there's different versions, there's different vulnerabilities within those packages that you're using as part of your application. So open source analysis and any package, third-party package that you're using as part of the application needs to have the same type of stringent view from a security lens as your homegrown code. And not just accepting it, well, it is what it is. It works, everyone else works. I mean, it's kind of like an example I can give here. I talked to an organization years ago where there was, their config file for the application was in clear text, not potentially security aware or anything like that. And they said, well, I have to trust that. That's how I configure the application. Everything is pulled off of that file. And the security head of the information security team basically said, well, what if that file is just switched out? You're trusting it explicitly. Just like the Spring framework that you're using, you're just trusting it explicitly. You should make sure that all the proper settings are included and configured, and if you have to tweak those based on the risk in the application, you need to go down that process. Because again, it's not just convenience, it's about the security of the application and the reputation of your organization. Does that make sense, or is that what you're looking for? Okay. Anyone else? No? Okay. Moving on. Demo. Here's where we're going to see something in action. So this demo is a Android app. There are two medium issues combined together. Two medium issues combined together can lead to a major vulnerability. The two issues, again, by themselves, harmless, a little bit of risk, but brought together, we're going to show you an application running and then an exploit app that was built that basically feeds off of the side channel data leakage. The DB is world readable, and a static encryption key, an encryption key that does not change over time. So what I'm going to do is do a quick little demo, and I'm going to walk you through this right now to show you the process. So, is that showing up okay? Okay. So we're going to, and instead of, I'm in front of you, we did this as a recorded session just so there's no hiccups during the presentation. I'm going to walk you through the process. So the first thing we do is we're going to launch this Money Manager app and log in. Has a passcode, it is secure. We're going to go into the Money Manager app, and we are going to create a new account. The new account is going to be called Savings. And we're going to do an initial deposit into this account of $50,000. So we created a new account in this app. We added some money to it. We can see that it's reflected in the balance. The original balance was $30,000. We've just added $50,000, so now there's a balance. Okay, we did some actions, typical of a banking app. Any app, retail app, healthcare app, anything. The exploit app basically pulls in that data, pulls in those two vulnerabilities, and I'll slide this to the side so you can see and remind, the side channel data leakage and the static encryption key. So we'll go into the exploit app and connect to those things, and you see that we could see in clear text the passcode, the balance, and the savings. So these two harmless things by themselves have now produced somebody can actually build an app on top of it, do the same connection, use the same encryption key, decrypt, and get into that application and see the data. So to prove that this isn't just a smoke and mirrors type demonstration, we're going to show you that we're going to go in and change the passcode for the account. Provide a new passcode, 555, re-enter it. Okay, great. Passcode's been changed. We'll go back out of the application into the exploit application. We'll verify that it does work. Go into the exploit application, and you see the passcode has changed. So even though there is a vulnerability in the application, and you may initiate saying, oh, we might have had a vulnerability, might be an issue, change your passcode, that'll do it. If these two vulnerabilities are prevalent, the side channel data leakage and the static encryption key, even if you go through the process in the application to say, okay, change your password, change your login, there might have been a breach, doesn't matter. because it's circumvented. It's about the encryption key being static and not changing with it. So these are the things you have to think about, is these Molehill vulnerabilities becoming Mountainous exploits, how disassociative issues that are harmless by themselves can be brought together for a real vulnerability that could potentially cause major pain. And the immediate response, I mean, we'll talk about, everything's topical, the Equifax breach. What if they went out and just said, okay, change everything? Doesn't matter if they've already had access to the data, and they can, even if you change it, they can still get at the data. So just being reactionary and not thinking real world or the depth and level of expertise associated with the vulnerability is critical. So it's not just about securing the application, it's how you respond to something that's been identified as well. So I'll close this down, and we'll jump back into the presentation. Oh, excuse me. Sorry, I'm getting glare off my glasses. So more security touch points equals on-time delivery. What was just mentioned before is late in the life cycle, you find an issue, you identify an issue, it stops the release of the application, it stops a revenue stream. If that application is supposed to be out on a day and it's determined to generate, let's say, $100,000 of business a day, and is delayed 5 days, now you delayed $500,000 in business because of the security vulnerability. So the more security touch points you have in your SDLC or DevOps program, it equals more of an on-time delivery and a better metric for on-time delivery. What do I do with the thing? Ah, there it is. So this is what should happen in a program. Again, we had this without the touch points. You should be ingrained with the planning and the design phase. Security should start from the beginning of an application. Even if it's a legacy application that's a living, breathing organism that's constantly changing over time, in that next planning phase, that next release, the next project management activity around it, include security in that phase. The biggest thing, and I harp on this ad nauseum, integration automation is key to the security program. If you don't have integration automation, the program is going to fail. There's thousands of developers with hundreds, if not thousands of applications in large organizations. If you do not integrate and automate, you cannot keep up with the flow of release. I've seen sprints happen in organizations 3 times a day, 10 times a day. There was one organization that was doing 15-minute sprints. How can a security team that is staffed by a small group of people manage the risk of the work of a very large population of development staff, release engineers, so on and so forth? So you have to integrate, automate, continuous testing, and validate, and do the SDLC or have the SDLC cyclical and not linear. Circle those back to the developers through the normal channels. A bug is a bug is a bug, so why don't we circle them back through the same delivery mechanism, which is your defect tracking system, and not be an out-of-band process that comes into a bug defect meeting or a triage meeting, whatever your organization calls it, puts down a big stack of paper and says, these are the things you got to fix. That's out of band. That's not going to be effective. You need to be part of the process and map to the SDLC and really have it as a secure SDLC that is about remediation, not about identification. Just a quote. Everybody has to have a quote. This is the one that was chosen for this presentation. But just talking about security can no longer be out of band or outsourced. And I know everybody in the room can read, so I'm not going to, read the quote for you, but it's just food for thought. And we're kind of wrapping up, and we're going to leave some time here for Q&A, questions, comments, agreement, disagreement, just open kind of communication between everybody, because I think a lot of people come to these conferences for that type of communication. But you need to really address the lack of secure coding skills. There's a lot of different ways. Checkmarks as an organization, we really focus on being proactive in that process and educating everyone, and we have a platform that really allows for that. But put some thought into secure coding education and preferably gamify it. You want it to be interesting. You don't want it to be boring stereo instructions. And it's very difficult. You don't want to actually sit down and be reading, uninteresting documentation that's hypothetical. You want to see not only why it's an issue, but what would it look like in the real world? Talk to the development staff about, okay, a SQL injection, cross-site scripting, cross-site request forgery. How does that propagate itself? What does it look like? You have to actually go that step and not just say, okay, If you're worried about SQL injection, you got to parameterize your SQL. Great, what does that mean? How does this work? What would be the danger to me? Why is cross-site scripting dangerous? How can somebody formulate an attack? So when you train the development staff on how to fix vulnerabilities, don't just train them about the baseline understanding, train them about how to fix it and why it's a risk. Analyze short pieces of code more often. You have to be proactive. You have to shift left. Short pieces of code result in short lists of vulnerabilities. Don't look for everything under the sun. Look for the things that are important to you that are of risk and keep those as part of the process as you move through.
I find one of the problems with that is we use Fortify source code scanner. So if you analyze a short piece of code, you don't have the whole call stack. So it's validated at the input, but that's not in the short piece. So you get a false positive because Fortify can't see that it was validated, even though we did input validation. So that's what I find. It's great, you know, to say short pieces give you short stuff to fix, but you don't have as much context to know if it's false or real.
100% agree. And what I'm meaning here is, let's give an example. Say you have a framework in your application, a framework in your organization. It's the UI framework, and that's used by every application that you build. Scanning that or investigating that, you're going to find the vulnerabilities in that piece of code and remediate them so they're not propagated over and over again in every application that uses that. And I agree with you that fixing that component and the vulnerabilities that are resident to that component are very, very important, but scanning the complete application at build time is just as important. So the short bursts of code is you want to fix the vulnerabilities that are resident there so they don't propagate themselves over and over again. So you're spinning your tires, fixing something in many different areas, but then in the build, you fix it as well.
Yeah, but now with microservices, you got 20 builds, and you got 20 separate pieces of code, so.
Understood. Microservices, I mean, you can scan the microservices, but you know, those are usually very small pieces of code. I mean, how big are your microservices typically in terms of lines of code?
I don't know.
Big?
I don't know, what's, you know.
Couple hundred lines of code?
VM's a microservice if I choose to, but the point is, the scanning of the code, if it's a microservice, is going to be that little piece. Again, you miss the whole call stack, which is sort of, well, I'm saying pen tests need to be better and not the code scanning now that you're breaking this code up into separate executables.
Yeah, no, I agree. I mean, it's a process that you don't want to just do one or the other. You have to do both. Yes. That's what I'm saying, is you have to do the small pieces because if there are vulnerabilities present in those small pieces, you fix those, and then maybe the whole data flow, the source to sync, the entry point to execution isn't propagated until you're into the build system, whatever it is, Jenkins, TFS, whatever you're using for your build. That's where you see that full data flow. But it's drips of data throughout that SDLC. It's not just doing it all at once, either in small components or big components. It's doing it at every step. And I'm very familiar. I was actually, from a historical standpoint, I'm with Checkmarks now. I was actually one of the first technical field people for Fortify back in the day. So I know exactly how it works. Back in 2005, and I'm dating myself, before static analysis was mainstream like it is now. So I know exactly what you're talking about, but you have to do both. You have to do the small pieces of code and the entire application. And one is not better than the other. Just like doing static analysis and dynamic analysis, you really need to do both. You cannot do just one and feel comfortable because things happen at runtime, things happen statically before the code is compiled. Any other questions? No? Okay. Developer adoption is key. And this is what I'm saying is creating a culture of development security working together. Build awareness and measure developers by code quality and code security. They can't fix what they don't know. So if you're the security team and you set policy, but you don't communicate that to the development team that's working on the next release, saying these are the things we can't live with in our code, and then you come back and they see security coming as the code police and are yelling at them and calling their baby ugly, you're going to get pushback. You need to publish and communicate what the policy is, why it needs to be fixed, which goes in with the training at the top, and communicate that and have a champion or have a security person that has meetings that happen on a frequent basis. I've seen organizations say, oh yeah, we have that type of meeting, we do it once a quarter. That's not enough. That application has changed so much from one quarter to the next. So you have to set the policy, you have to communicate what it is, and you have to provide a source of information to have a conversation about it. And
what about coding style guides? Because typically that's kind of what drives a team of how they should be doing things, how they should default things.
Style guides in relation to security or style guides just in relation to the code itself?
Typically developers will have that, like, okay, we use these certain libraries, they're here. We do these certain configs, they're here. Have you ever encountered that?
Absolutely. I mean, but from a coding standard, it's the way you structure your code or the way you use your code. It may be an instance. Let's give an example of error handling. So if you have a style guide and you're thinking, okay, I did sanitize the input, and I sanitized it at this flow. The data flow is 10 steps. I did it at step 7. I used the correct sanitization in the standard, or you call it a security style guide for that. But there's an error handling, something that happens in error handling that recovers above the sanitization and basically circumvents it and goes back in and recovers and comes back through. Even though you've used it technically, you have to think about all aspects. So just saying I used the style guide or I used the security frameworks that are associated with that data flow, you have to make sure that you test it as well, because there are instances where even though you're using the correct components, the correct settings, you mentioned the settings or using the standard settings, you have to make sure that you're doing double checks on everything, because there may be instances that go outside the bounds of the intended purpose. Does that make sense? Do you agree or disagree?
No, I agree. It's just more of that when you have new devs come in, they sometimes bring their own practices in, and that morphs over time.
Well, and that's where communicating, if it's communicated up front that these are the things we cannot live with in code, that you need to sanitize any untrusted data entering the application. You have to parameterize your SQL statements. You have to do these things and educate them and give them the data. If they have their own style, you can augment their own style with the demands from the security team to protect the applications. And that kind of goes hand in hand with the security policy and the threat inventory of the application itself. These are the things we do for our high-risk apps. These are the things we do for our medium-risk apps. These are the things we do for our low-risk apps in terms of security. Any other questions? And again, you don't have to agree with me 100%. There's not one right or wrong answer. If the style guides work, that's great. I'm just giving you food for thought to think about the edge cases, because the standard is secure. Usually if you're doing the right things, it's the things that go outside the bounds of the intended purpose or the intended program, the processes of the program. And again, the last one, have developers and security engineers, or the second to last one, work side by side, literally. Do not work in your own bubble. I was at Jenkins World 2 weeks ago, talking to the DevOps team, the people that are responsible for the DevOps team. I asked a lot of them, and I had some great conversations saying, well, how do you guys work with security? We don't. They're over there. We define the DevOps program, the CI/CD process. We don't talk to security. That's a recipe for disaster right there. And a lot of organizations, how many people feel they have a true 100% efficient DevOps program right now? How many feel that are in transition and moving to that right now? A lot of organizations, yeah. That's the common, people say we're on a road to that. We're not there yet. Well, if you're on the road to it, to implement the program, you should bring security in. They shouldn't be that team that sits off to the side while you're defining a DevOps program that's going to release and change your applications over time. They need to be part of that program, part of that conversation. So they literally have to work hand in hand. And I really strive to have those meetings and to bring those people together so that they do define a program that's not only efficient in terms of software release, but it's also secure when you release that software. Again, I harp on this, shift security left and automate and also integrate whenever possible. This is the only way that security is going to effectively identify and provide you the data points for remediation of the risk. If you don't automate and integrate, you're going to potentially have some problems. Because, again, the DevOps train, your SDLC processes are flying down the tracks at 1,000,000 miles an hour. If you don't automate that, the security teams can never catch up to it. That was the presentation. I told you I'd give you 10 minutes at the end for Q&A. Are we still good? Okay. Again, mine is Matt Rose. That's my contact information. If anybody wants to chat with me afterwards, I'm going to do QA, so don't run away. If you have somewhere else to go, that's totally fine. I have cards and any information. But any questions, comments, general statements about the presentation?
Hi. So to follow up on your assertion that a couple of medium risk vulnerabilities can create a severe risk, I'm wondering if there are certain types of medium risks that you can identify as possibly leading to, because honestly, the example that you gave of the static encryption key, I would say a static encryption key is already a high risk. I like that doesn't seem medium to me.
It's about, is it an exploit by itself? And so thinking about those type of things, is it an exploit unto itself? And really, it goes to the threat inventory of the applications. What is it doing? How is it interacting? And you can basically think about potentially what happens if I don't, if the static encryption key is prevalent. What are the things? And these are where the security has to educate development staff. How much easier is it to change that or remediate it than actually just accepting the risk? Because a lot of times, like that example I gave with that buffer overflow, it took 10 minutes to fix. Let's go through the process and fix it. But it's hard to say what are the medium vulnerabilities or vulnerabilities that you should consider dangerous if combined with other areas. And that's based on the security policy and the threat inventory of the applications and just the policy that you're trying to have the developers enforce.
But you don't have like any, rule of thumb, like
We do in the
these ones are like
I don't have them off the top of my
pretty
head.
innocuous.
Yeah, I don't
But
have
that
them
would
off the
be-
top of my head, but
Oh,
you
thank
definitely, if you come by the booth, you can talk to our engineers. We have what we call presets in the product that basically do that for you, that really identify what are the ones you should really fix and why, and it tells you this one combined with this one could be an issue. So you might want to think about both these holistically to remediate rather than just like, I'm only going to look at high-risk vulnerabilities. Yep. Anyone else? In the front here?
The training that I attended the last couple of days actually put forth the idea of doing threat modeling, in the beginning of the cycle, and then creating abuser stories that are linked to the user stories that can help the development team kind of put it in front of them to see how their application could actually be exploited. So it's, I think that's kind of an interesting idea. Do you have any thoughts on whether, how effective that could be with kind of integrating with the development team and communicating better with them through those abuser stories?
Absolutely, and we at Checkmarks do the same type of thing. Part of our application onboarding process, the technology finds the vulnerabilities, but if you're doing a threat modeling and understanding what the application is doing, you can tune the static analysis platform to identify based on that threat model, based on those kind of plays or use cases that you're having. So when you do that, you're actually focusing the attention of the static analysis platform on the vulnerabilities that fit the threat model as you're going through that process and fit those stories. So it is a critical part of the process. Just turning on static analysis or turning on dynamic analysis is not enough. There are other steps you have to do, and threat modeling is a great way to start because then you understand what's happening in the application, what you're concerned about, and talk about, with the development staff, these are the things that we're seeing happen. Could this potentially happen in the application if, things go awry, if somebody puts this type of input into the untrusted entry point or a web form or a query string or whatever it is, you can definitely do that. So I think that's, I'm spot on. I'm in total agreement with you that threat modeling is a great step to understand the risk. So you go down the process with a plan mapped to a policy that leads to remediation and identification. Any other questions? No? Well, thank you very much. Our booth is down there. I walk the halls. I'm up here if anyone wants to have a side conversation or expand on anything I said. Even if you want to disagree with me, that's totally fine. I got thick skin. I know everybody has their opinion and does develop software differently, but I appreciate your time and have a good rest of the conference. Thank you.
Thank you, Matt.